Hey everyone, welcome back for another lesson on chemical reactions. This time, we're going to take a look at double replacement reactions. So the usual giveaway to identify whether or not we have a double replacement reaction occurring is if your reactants are a compound reacting with another compound, and these two compounds will typically be aqueous solutions of ionic compounds. So like the name will suggest, in a double replacement reaction, we have a double replacement occurring where the cations of the two ionic compounds essentially swap with one another and bond then to the adjacent anions that were originally present. So in our example, for the lead 2 nitrate and the potassium iodide, the lead and the potassium will swap the ions that they're bonded to. So the lead will then bond to the iodide, the potassium to the nitrate, and we form two products. This is equivalent to what we see in algebra, where although not a one-for-one example, it's similar to the approach of how we FOIL, where our inner and outer ions are essentially swapping the ions that they are bonded to. Now, the one thing that we need to keep in mind here is that in a double replacement reaction, our new products must adjust for the difference in the charges in the ions. So although it might be habit in order to try to carry over subscripts from the reactant to the product side, we must readjust our compound formulas in order to include the new balanced charges on the product side. In addition, to ensure that this reaction essentially takes place, we want to check that one of our products forms a non-aqueous product. So we have to check out what are the products formed, and at least one of them must be a solid, liquid, or gas. Should this not be the case, if we make two soluble products, as in both products are in the aqueous state, essentially no reaction occurs. So this is the one thing to really keep in mind for a double replacement reaction, is that they don't always occur. We need to have one non-aqueous product. So let's take a look at an example on how to write a double replacement reaction. So for our first reaction, we have sodium hydroxide bonding or reacting with copper 2 chloride. So in this case, our cation swap, sodium and copper will swap with one another. So then that means the sodium will bond to the chloride and the copper to the hydroxide. So our first product will be a combination of sodium and chloride, giving us sodium chloride. Our second product will then be a combination of copper and hydroxide. We can tell from the copper 2 chloride formula is a positive 2. Hydroxide, which is negative 1 charge, gives us the chemical formula CuOH2. So here we can see that we have to balance our charges because we now have a new combination of ions. Now lastly, to ensure that the reaction even takes place, we need to check the solubility of our products. Sodium chloride is a soluble compound, and so its state of matter in this reaction would be aqueous. Copper 2 hydroxide, however, forms a precipitate because it is not soluble in water. Since we have ourselves one non-aqueous product, this reaction does in fact take place. And now the last step to do is just balance our equation. And now we have our full, complete double replacement reaction. Let's look at one more example here with magnesium nitrate and sodium sulfate. Once again, our cations swap with one another, so magnesium and sodium will switch with whoever they're bonded to. So now magnesium will bond to sulfate, sodium with nitrate. So our first product is going to be a combination of magnesium and sulfate, giving us the formula MgSO4. Our second product will be a combination of sodium and nitrate, giving us sodium nitrate. Lastly, we must check the solubility rules. We see that magnesium sulfate is a soluble product. Same thing applies to sodium nitrate. Because we've essentially made two soluble aqueous products, this reaction actually would not take place, and the correct way to represent this reaction is with an NR to signify no reaction. So that is the one thing to really keep in mind here, that for the double replacement reaction, we must check the states of matter of our products. One of them must be non-aqueous in order for the reaction to occur. Should we have two aqueous products, then we just, instead of writing our products, would substitute with NR.